A great way to get a representative sample is to use random selection, but it's not perfect. It is helpful in reducing bias. And as you increase your sample size, it does a much better job. Let's start off by taking a look at a sample size of 5. The population we're going to be looking at is slightly skewed. The mean is 24, standard deviation is 6. If we were to look at it with the normal curve, you can see it's somewhat close, but not perfectly there. Here are those samples of size 5. The red dashed line represents the population mean, and the solid green line represents that of the sample. And you can take a look at, for our first sample, it's not representative at all, since every single value came from above the population mean. As we take a look through these samples, there's a fair amount of variability in some cases between the sample mean and the population mean. When the sample mean and the population mean are really close, we would say in that case that there's much less sampling error. The sample gave us a good idea of what the population mean is about. In cases where the sample error is larger, then we would say a sample is not representative of the population because there's so much difference between it and the population. All right, let's consider this now for samples of size 25. That's a much more typical sample size when you're doing psychology research. In that case, you can see that, again, there is some variability between the sample mean and the population mean. It tends to be less than for the sample size of 5, and that's what we would expect. Also, when we take a look at this, we get a little bit of a hint that there's some negative skew, and that we have more values that are close to the sample mean on the right, and on the left we see these values are a little bit more spread out. Okay, what about for a sample size of 100? For a sample size of 100, take a look now at how similar the sample mean is to the population mean. For sample 2, they're literally right on top of each other. The better the sample is at representing the population mean, the easier it would be to detect later on an effect of a treatment. So again, our sample means are really close to that of the population mean, and the distribution for the sample is much more resembling that of the population. Finally, we'll go with the sample size of 1,000. So here we go, and you can see that in that case, the sample mean is almost perfectly aligned with that of the population mean. This is a good indicator of the law of large numbers, which says that as the number of trials increases, your estimate, that is the sample mean, will more closely approximate the parameter, that is the population mean.